In the last chapter of Mastering AMC 1012, we covered geometric sequences and an interesting application, as you can see over here. And we also use algebraic manipulation to help us. This time, we're covering special sequences. Make sure to stay till the end, because we're going to solve a very cool special sequences problem with telescoping. Okay, so some common special sequences. The sum of numbers from 1 to n is n times n plus 1 divided by 2. The sum of odd numbers is n squared, because we can pair the terms up and we end up that the average terms is n, and there's n of these terms. So n squared is the sum. That's something that's very useful to memorize. The sum of even numbers is just twice this sum, so you can think of it as just n times n plus 1. The sum of squares formula. Now this is something some people have hard time memorizing. Basically, it's n times n plus 1 times 2n plus 1 divided by 6. And the easy way to remember this is n times n plus 1 divided by 2 times 2n plus 1 by 3. So this is the sum of numbers formula, and you multiplying that by an additional 2n plus 1 by 3. Here. The sum of cubes formula. Now this is a very cool one. It's just n times n plus 1 divided by 2 squared. So the sum of cubes, as counterintuitive as it may seem, is the sum of numbers squared. Okay, now we're going to take a look at this problem over here. And this problem uses telescoping. So telescoping is where you expand the first few and last few terms, and you cancel out terms. So whenever you have long expressions, they may seem very hard to compute. But telescoping, you get rid of most of them, and you're left with just a few survivors. Let's take a look at this example over here. Consider the sequence defined by a of k equals 1 over k squared plus k for k greater than or equal to 1. Given that a of m plus a of m plus 1 all the way till a of n minus 1 is 1 over 29 for positive integers m and n such that m is less than n, very important, find m plus n. That's a mouthful, isn't it? Let's first deconstruct a of k, because that's really the heart of the problem. A of k is 1 over k squared plus k. Let's take a k out. It's k times k plus 1. Now, what is that equal to? Well, it's 1 over k plus 1. That just seems like an arbitrary expression. You might be wondering why I'm asking you to find what that's equal to. It's already simplified, right? We don't care about simplified expressions here. We want something that cancels. Let's take a few examples. 1 over 2 times 3 equals 1/6. Now, if you've done a lot of operations with fractions before, you know that this is 1/2 minus 1/3. Another example, 1 over 3 times 4 is 1/12. You probably know that this is 1/3 minus 1/4. Now this right here is starting to not seem like a coincidence anymore. Maybe, is it true that this is just 1 over k minus 1 over k plus 1? Let's verify. What is this quantity equal to? That quantity is just k plus 1 over k plus 1 times k minus k over k plus 1 times k. If you subtract these out, we're just left with 1 over k times k plus 1. Isn't that cool? So now we have 1 over k minus 1 over k plus 1. What do we do with that? I mean, it's just a bunch of 1 over terms. Now the trick is, now we look back to the other part of our problem. A of n plus a of n plus 1 all the way till a of n minus 1 is 1 over 29. What is a of n? 1 over m, let me write it a little lower so we have more space. 1 over m minus 1 over m plus 1. What is a of m plus 1? That's 1 over m plus 1 minus 1 over m plus 2. What is a of m plus 2? 1 over m plus 2 minus 1 over m plus 3. Dot dot dot, all the way till, what is a of n minus 1? 1 over n minus 1 minus 1 over n. You'll probably have seen that these terms are equal. These terms are equal. And maybe we'll just cancel them out. They just cancel out. This is just 0. This is just 0. And so on. We'll just remove, these terms will all cancel out. And it turns out that all the terms will cancel out. The 1 over n minus 1 will cancel with the previous term. The only terms that won't cancel out are these edge terms. Everything else will cancel out on the inside. Because 1 over n minus 1 will cancel out with the negative 1 over n minus 1 in a of n minus 2. So by that logic, everything in the middle cancels, and there's two survivors on the other side. 1 over m minus 1 over n. And we know that this is 1 over 29. Now the trick here is to see that there's actually two ways to proceed from here. The first way is to see that this term over here has to be a little bit less than 29. So you can maybe infer what this value would be and then do a little bit of guess and check from there. But I'll show the more rigorous way, which is to multiply everything out by 29mn, which gives us 29n minus 29m is mn. Mn plus 29m minus 29n equals 0. Now, we could use Simon's favorite factoring trick here, which means that we subtract negative 841 from both sides. And from here, what we notice is that these two terms have m in common. So m times n plus 29. These two terms have a negative 29 in common. So negative 29 times n plus 29. So from here, all we do is we group them together, and we're left with m minus 29 times n plus 29. And this is negative 841 because, remember, subtracted from that from both sides over in this step over here. So now we have a negative on the right side. Let's just make this 29 minus m instead. So this become a happy positive number. Now 841 is just 29 squared, and m and n are positive integers. So if m is a positive integer, 29 minus m will be a number that's less than 29, less than, not equal to, strictly less than 29, because it's a positive number, and it obviously can't be negative or 0. So the only factors of 29 squared are 1, 29, and, well, 29 squared itself, which is 841. 29 minus m is less than 29. Guess what's the only factor less than 29? 1. So 29 minus m is 1. So n plus 29 equals 841. So n is equal to 812. Because 841 minus 30 plus 1. And m is equal to 28. So their sum, what the question is asking for, is 812 plus 28 equal to 840. This is the final answer. Because this is just the sum. And now we're done. We're ready to move on to the next problem. Let the sequence a of n be defined as a of n equals 3 plus 1 plus 2 plus 3 all the way till n. Let's write some terms of a of n so we understand what's happening. A of 1 is just 3 to the 1. A of 2 is 3 times 3 to the power of 1 plus 2 all the way till n. A of 3 is 3 to the power of 1 plus 2 plus 3, and so on. We kind of get what's going on. This is 3 to the 1, this is 3 cubed, This is 3 to the 6. You might notice that these are triangular numbers over here. Sohail is trying to evaluate the following sequence or expression. 1/2 times 2/3 times 3/4, so on. But he accidentally writes a plus sign instead of a multiplication sign before all fractions of the form an over an plus 1. So for example, an is these three terms or and beyond, as we saw here. So the fraction 3 to the 1 over 3 to the 1 plus 1 would be a fraction that Sohail writes a plus sign instead of a multiplication sign in front of. Similarly, 3 to the 1 plus 2 over 3 to the 1 plus 2 plus 1 for a of 2, which would be a of 2 over a of 2 plus 1. Instead of writing a times here, Sohail writes a plus. So now, what is the value of the new expression over here? So the original value is 1/2 times 2/3 times... Oh, but I accidentally write a plus sign before something like that. What are all these values an over an plus 1? Well, the first one is 3 to the 1 over 3 to the 1 plus 1 is 3/4. So before 3/4, I write a plus sign. Then it's again times 4/5 times 5/6 times 6/7, all the way until when do I next write a plus sign? At 3 to the 3 for a of 2 over a of 2 plus 1. Because that's what it says here, before a of n over a of n plus 1. So that is 27 over 28. So all the way I'm writing times until 26 over 27. Then I'm adding 27 over 28 times whatever comes next. Then we keep going. Let's keep going over here. Times 28 over 29 times 29 over 30 times, when do I next write it? 3 to the 4 over 3 to the, or not 3 to the 4, sorry. 3 to the 6, right? 3 to the 6 over 3 to the 6 plus 1. 729 over 730. All the way till 7, I write all the way a times, all the way until 728 over 729. So now the mistakes are getting a little less often. And then plus 729 over 730. ... so on. What is this value? Seems like a scary expression, but it'll simplify very nicely at the end. First of all, what's 1/2 times 2/3? 2's cancel, we're left with 1/3. Then what's 3/4 times 4/5 times 5/6, all the way till times 26 over 27. 4's cancel, 5's cancel, 6 cancel, all the way until 26 is cancelled. And we're left with 3 over 27. Now, what's next? We've got this term over here before we have another plus. 28 cancel, 29 cancel, 30 cancels, all the way till 728 cancels. We're left with 27 over 729. And we keep going. What is this? Always simplify your fractions. This is a third plus a 9 plus a 27, 1 over 27. Wow, isn't that an infinite geometric sequence? This is an infinite geometric sequence with first term 1/3 and common ratio 1 minus 1/3. So it has a value of simply a third over 2/3 equals half. That is the answer. Now the trick here was to not get scared by all the scary notation and just see what's going on. We did that and almost everything canceled, and we're just left with these simple terms over here. And then they simplify to a simple infinite geometric sequence, which we can evaluate using our formulas. And that's it for this problem. Up next, we have a problem from Amy. In this problem, given that x1 is 211, x2 is 375, x3 is 420, and x4 is 523. We're given xn is xn minus 1 minus xn minus 2 plus xn minus 3 minus xn minus 4. for all larger values of n. Find the value of 531 plus x of 531 plus x of 753 plus x of 975. Wow, that seems like a scary recursion right there. Got 4 terms that we're adding or subtracting. Now the trick to solving these is don't get scared, just write out a few terms. Maybe you'll find a pattern. And that's exactly what I'm going to do. So we know x1 is 211, x2 is 375, x3 is 420, x4 is 523, x of 5 will be x of n minus 1, x of 4, minus x of 3, plus x of 2, minus x of 1. What is this? Well, 523 minus 420 is 103, plus this over here is 264, or 164. So this is summing to 267. X of 6 is equal to x of 5 minus x of 4, so 267 minus 523. And then after that, we add back xn minus 3, which is in this case x of 3 minus x of 2, 375. This is, well, what is 267 minus 523? That's 523 minus 267. What is that, first of all? That's just 223 plus 3, which is 256, right? So then this will be negative of that. Negative 256 plus 45, which is negative 211. Wait a second. Negative 211? Positive 211? Is that maybe something is going on there? Let's find one more term. X of 7 is negative 211 minus 267 plus 523 minus 420. And if you do evaluate this, which I'm not going to show, but if you do evaluate it, it will be equal to negative 375. Aha. Now you definitely know something is going on. There's some kind of a pattern going on here. And there's 2 ways to continue from here. One is you can finish the pattern and then just see where in the pattern one of these terms would lie by looking at sequences, kind of like digit cycles, except in this case we have a sequence cycle. But I'll show the smarter way to think about it, which is to notice that if x of n is equal to xn minus 1 minus xn minus 2 plus xn minus 3 minus xn minus 4, if you write something else, maybe xn plus 1, this is xn minus xn minus 1 plus xn minus 2 minus xn minus 3. Now the thing to notice here is that these terms will actually cancel. Cancels, 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 cancels. Now this is telescoping except in a different way, as you can see here. We're left with x of n plus x of n plus 1 is x of n minus x of n minus 4. These terms will cancel, and we're just left with x of n plus 1 is x of negative of x of n minus 4. So what does this mean? This means for any value, let's make a substitution here. For any value a, let's say negative x of a, where a is n minus 4, is equal to x of a plus 5, because n plus 1 is 5 more than n minus 4. What does this mean? This means that essentially we're cycling every 5, except the second cycle will become negative. So what does that mean? That means we'll have essentially 211, 375, 420, 523, 267. Then negative 211, negative 375, negative 420, negative 523, negative 267. Because all these terms will be negative of it. So it's kind of a sequence of 5, except the second sequence of 5, they will alternate between positive and negative terms. But on the third one, we go back to being positive, because this time it's negative of the previous negative term. So a of 11 is negative of a of 6, but a of 6 is negative of a of 1. So this is just a of 1. And so on. So from here, now we just have to see where this lies in our cycles of 5 and seconds, or essentially it's a cycle of 10 with positive then negative. It's a full proper cycle of 10. So x of 5, 3, 1 is the same as x of 1, because after cycles of 10, it just repeats. X of 1, 2, 11. X of 7, 5, 3 is same as x of 3, 4, 20. And finally, 9, 7, 5 is just 2, 6, 7. Let's add them up. We get 631, 2, 6, 7, 8, 9, 8. That is the answer for this one over here. Now there's some practice problems which you can find in the free Mastering AMC 1012 book, link in the description. It's completely free. But next off, we're going to move on to systems of equations and speed, distance, time. Now those are also very common topics on the AMC 10 and 12. And the key is to use algebraic manipulation along with setting up an equation. We'll be discussing that in the next video over here. Also be sure to like and subscribe